Hello there, in this video we are going to be looking at section 2.1.2, computing hardware, and in particular we're going to be looking at binary logic. OCR say that you need to be able to explain why data is represented in computer systems in binary form, understand and produce simple logic diagrams using operations not and or, and produce a truth table for a given logic diagram. So, data is represented in computer using binary form. Binary ones and zeros represents on and off state in circuits. This means it's easy, it's simplistic, it can be looked at and viewed at from the PC really easily. Here we have the three logic diagrams which are required of you for the OCR Computing GCSE. First one, on the left hand side of the triangle in the little circle, we have got a NOT gate. And essentially what that does is it inverts, it flips over whatever's being put in. So the input is A, goes in through an NOT gate. Q is the resultant. So if A is 1, when it goes through, the result is 0. If 0 goes in, 1 gets output. So if you're thinking about this as a circuit, ones and zeros, ons and offs. So if it's on going in, it gets flipped off. If it's 0 going in, it gets flipped on. The middle diagram, which looks like the big D, is an AND gate. And what this is looking for is looking for values A and B to both be true, both be 1. So for example, if it's 0 and 0 go through, it's going to result in a 0. 0 and 1 go through, it's going to result in a 0. 1 and a 0 go through, results in a 0. The only time it results in a 1 is if there's a 1 and a 1 going in. Finally, if we're looking at the OR gate, which is the one on the right hand side, which looks like kind of like a half moon, this is looking for one of the two to be set as true. So for example, 0 or 0 is going to result in 0, but from that point onwards, if one of them is true, is 1, it's going to result in 1. And what these do, this is the basic breakdown of how things work on a PC. So there are millions of these gates all over different pieces of electricals all over the world, and it converts ones to zeros, zeros to ones in different ways, shapes and forms. This is the very basic building blocks of computer science. This is where the science really comes into play. Finally, producing a truth table for a given logic diagram. And again, I've just kept these images here just to reinforce what's going on. When you get given a logic diagram to complete or to work out what the final value would be, it's very easy to get overwhelmed by what's going on. You see lots of these different shapes, you don't know what's going on, you panic. Break it down section by section by section. Look at each individual shape. Start from the left hand side where you've got all the different values going into it and work your way through slowly. Create these little logic tables, which you can see at the bottom, to help you understand and work out and show your workings so you can show your knowledge. It will help you hopefully pick up some marks to show to the examiner you know what you're talking about. Don't panic if you see a massive logic diagram in an exam. I hope this has been helpful for you. Feel free to like, comment and subscribe, and I'll see you in a future video. Bye bye.